Hello everyone. In this assignment you'll be showing your understanding of the types of solids that exist. So you would have hopefully already done the types of solids lessons. So your goal is here to predict the type of solid formed by a chemical substance and describe the properties of that substance, and also explain how physical properties depend on the types of inter and intramolecular force. So in this unit we're trying to connect the idea of what's happening on the small level, so the atomic level, translates to larger things like what's happening to an entire material in its terms of its physical properties. So you are required to use full sentences and proper course terminology, so please do that as well. So there are a couple parts to this, so I'm going to go through each part separately. Part A asks, what are the differences between a crystalline solid, a polycrystalline solid, and an amorphous solid, and then give a specific example of each one. So in each one you're going to explain what the differences are, so what makes it that type of solid, and then give a very clear example, so an actual material that falls under that category. You are welcome to sketch them as well. I know some people like to do that. That's why the box is pretty large. You can sketch them out at the bottom if you just want to show how the atoms are arranged in each one. The second part, part B, is just a chart that's going through the four main types of crystalline solids. So these are the ionic, molecular, covalent, network, and metallic. So I'm just going to go through these properties. So first one says identify the strongest force in the lattice structure. So my question here is, what is the strongest force? So when I use the word identify, I'm asking you to actually name it. So I'm not looking for is this is stronger, this is weaker. I'm looking for what is the force that's holding that crystal together. And for each one of these four, it's going to have a different force that holds it together. Hard or soft is pretty self-explanatory. Is it hard or is it soft? But the answer may not be that clear. It could be variable, so you can write that in as well. So you can write things like it's hard under these conditions or it's soft under these conditions, or you can say both. Remember that these are big categories, like the metallic category, for example. If you look at your periodic table, there's like 100, or I don't know the actual number, it's not 100, but there's a lot of metals, and so they could have different properties. So keep that in mind when you answer. Sometimes it's not an obvious answer. Brittle or malleable, so sort of the same idea. It could be one or the other. It could be some combination. If you don't know what these words mean, this is a perfect time to look them up and add them to a vocabulary list if you're making one of those. Does it have a high, low, or variable melting point? Again, this could be variable. I put it in the actual question this time. Is it a good conductor? So this is when it's in its natural form, when it's not dissolved in water. So in its natural form, when it's not in water, is it a good conductor? So you can write conductor, you can write insulator, you can write poor conductor, anything that makes sense to you as long as it's accurate. Solubility, so is it soluble? And by solubility we mean in water. So is it soluble in water? Does it dissolve well, or does it not dissolve at all, or is it somewhere in between those? One example of the solid, again, straightforward, just give me one example, an actual material that falls under that category. So that's the chart. Part C is you're doing a little bit of application. You're going to take what you know about the solids and apply them to a couple of projects. So you are working as a structural engineer, and you're trying to determine which solids should you use for two different projects. Now, for each project, what you're doing is you're picking the most appropriate type of solid. So what I'm grading you on is the one you picked the best option? So obviously you could pick multiple things, but is the one you suggested the one that would have made the most sense? And did you explain why the other one wouldn't have worked as well? So of the four, so I did put here ionic, metallic, covalent, network, molecular. You can use other materials if you want. You just have to explain why you're using them. So you can say, I didn't pick any of these four because of this. I picked this material instead because I think it will work better. As long as you're clear on the explanations why. So again, what you're doing is clearly explaining your choice. For full marks, identify the specific solid you would use. So in other words, don't say metal. Tell me the exact metal. I'm going to use aluminum for this reason. I'm going to use gold for this reason, something like that. And then obviously, or not obviously, but also explain why the other types of solids are not the best choice. So for full marks, you're also explaining why the other ones wouldn't have worked. Again, what I'm looking for is, do you understand these solids? Do you understand their properties? Where could they be useful? Where might they not be as useful? Now, the other thing I'm pointing out here is to also consider the cost, and I do mark on this. I don't mean calculated. I mean, let's say you were making something and you say, okay, I'm going to make it out of gold because gold, doesn't rust or something like that. That's great, but you're probably not going to be able to afford that. And your boss is probably not going to like that you're suggesting that you make this big structure out of gold. So do consider the cost. Again, you don't need to calculate it or anything, but if you're not sure what something costs, do a quick lookup to make sure that a project that should cost maybe $100,000 is not costing you like $1 billion. So do check into that. So, project 1, you are designing a rubber tire for cars that is designed to seal itself when there are small holes. So one of the big problems with tires, you fill them with air. If you get a hole in them, all the air comes out and the tire doesn't really function anymore. So these are tires that are designed where if there is a small hole, there is a material on the inside that will seep over and cover that hole, and it will prevent the leak, and therefore you can just keep using the tire like normal. It has to be filled with air, so it is an air tire. And it has to be able to withstand the high pressures and temperatures that car tires undergo. So you can't make it out of something, for example, very brittle, because that wouldn't work as a car tire. So again, you're not redesigning things. It is still a rubber tire. You do know that. What I'm looking for is what's the other material you're using to help it self-seal. And you are welcome to research this. They do exist. I'm looking for, in addition to what you picked, why did you pick it? And that's what I'm really grading you on, is how well do you understand why that would have worked. So that's project 1. Again, you have lots of space there. Write out your answers. Again, I'm looking for a lot of detail here. For the second one, project 2, you are designing a drill head for a boring machine. A boring machine is a machine that is used to drill things like subway tunnels. So they just go underground and they just keep drilling all the way through. And this is for the Scarborough subway extension in Toronto. So if you're not familiar with it, this is an actual project. So you can look it up. So the TTC is supposed to extend past Kennedy. So just, a little information there. So the area the tunnel is being created in has been found to have dense clay and a high density of minerals like iron and copper ore. So obviously that means you have to be able to dig through that stuff. And the second part is that the tunnel will be 22 kilometers long. And so that I bring up because these machines are really big and they're really expensive. It's hard to put something in there, go for, let's say, 1 kilometer, the drill head breaks, and to get that machine back out to replace the drill head is a lot of work because you have to pull it all the way back out. So imagine if you were 20 kilometers in and it breaks, you have to literally pull it back 20 kilometers to get back to the drill head. So consider that. The other thing I'm going to encourage, of course, you can look up drill heads, see what they are. Again, do consider the cost in this, but at the same time, you can make drill heads out of multiple things. It doesn't have to be one material. So just a suggestion or an idea, but I do encourage you to do a little research. It'll help you with that. So that's the entire assignment. So hopefully that explained it. And if you do have any questions, please let me know.